So this is the desired reaction, 2 moles of N2 gas and 6 moles of H2O, which provides 3 moles of O2 and 4 moles of ammonia, and you need to calculate delta H. Now let me write down steps. The steps are given: 1/2 N2 gas, 3/2 H2 gas, and NH3 gas, and we have delta H, which is negative 46 kilojoules. Now in a second step, let's say H2O gas, and which provides 2 moles of H2 gas and O2 gas, and then delta H is positive 484 kilojoules. Now 2 steps, and that's our desired reaction. So now looking into this desired equation, we know that N2 is on the reactant side, right, and it's a 2 moles. Here we have 1/2 mole.
Multiply by 4.
So what we do, we can multiply by 4. Okay, so what you do, this reaction, I would say A and B, this one we are going to multiply by 4, so that way we get 2 moles of N2. Now in here, H2O, when you look at H2O, this is 6 moles and here we have 3. So what we do, multiply by 3, okay, and here we are not reversing or anything. So the main thing this is, we can do multiply by 4 for step A and multiply by 3 for step B, and then we add their delta H. Now what we can do, when you multiply by 4, you get, write down in this step, 2 moles of N2 gas plus 6 moles of H2 gas gives 4 moles of NH3 ammonia gas, and delta H is negative 184 kilojoules. When you multiply by 4, you get that. Now for step B, when you multiply by 3, you get the 6 moles of H2O gas, 6 moles of H2 gas, 3 moles of O2 gas, and then delta H, it is positive 1452 kilojoules. Now what you do, you add them together. When you add them together, 6 moles of H2, 6 moles of H2 cancels out. So what's our equation we get? 2 moles of N2 gas
Plus 6 moles
6
of
H2O
H2O gas.
gas, yep.
Arrow. 3 moles of O2. 3 moles of O2 gas. Plus 4 moles of NH3 gas.
Fantastic. And what we do, we add this to enthalpy also. When you do that, delta H for this particular reaction, we get positive 1268 kilojoules. Now when you compare this equation with the desired equation, we get the same one, right? Same equation. So what you do, these steps what you have, you manipulate in order to get the desired equation, and that's how you calculate delta H for that desired equation. That you can follow Hess law. Hold on, Hess's law. So delta H for this reaction, you can use Hess law and calculate it. Okay? All right. Now we'll work